All right, I know a lot of people say this, but I'm really nervous about public speaking, so I'll try to avoid eye contact. But thank you all for coming. The title of our talk is Gone in 60 Minutes, A Practical Approach to Hacking an Enterprise with Yasuo. And Yasuo is a tool that we wrote, and we'll talk about it in a while, if we get time. All right, let's get started. So I am Saurabh. It's pronounced as Saurabh Harit, and I work as the Director of Security Research at Security Compass. We are a pen test company based out of Toronto, Canada. In my day-to-day job, I do pen testing, and this is what I love, doing internal, external network pen test. Getting domain admin is an added bonus to the job. I started off as a reverse engineer, so I've had a secret crush on reverse engineering. And I'm a gym freak with bad eating habits, and I've got two beautiful dogs.
So, I'm Stephen Hall. As you can see, not much is known about me. I like to keep it that way. I work with Saurabh when I don't get on his nerves too much. And I unfortunately forgot my Santa hat. So, you can also see me in Toronto walking the streets in the middle of June in a Santa hat.
All right, so I wanted to set the record straight that obviously you all know it's a stable talk. We're not going to be dropping any ODAs, there won't be any shells, but something more important than a shell, if that makes sense. So let's set the scenario. So you are on a red team engagement, or you're actually trying to break into a company, you are a malicious user, and you bypass physical security, which is somewhat easy to do unless you have turnstiles or like rotating doors. It's pretty much easy to bypass physical security. You bypass NACs, as we've seen at some of the clients that they implement network access control. There are a lot of ways of bypassing NAC, which are out of scope of this talk, but from my experience, the most common one is to just look for unprotected NAC ports. If you see a router hanging from the roof or lying down on the floor, yeah, that's a moment of to smile. All right, what next? So what are you going to do after that? Are you going to run a vulnerability scanner? That's probably a bad idea because because as soon as you fire up a vulnerability scanner, all the network security devices just light up as like a Christmas tree. So and or if there's a vigilant network admin, that person will catch you for sure. So the problem at hand is that we have bypassed physical security, we bypass NAC, we want to extract data from the network and do it as quickly as possible and get out of the premises. But we can't run a vulnerability scanner because it's too noisy. So Nessus is a great scanner, but it sends out hundreds of thousands of requests. We have to be stealthy and quick. If we were on external network, we could use Google Docs, so like site, link in URL to find specific applications, right? And then go that route. But we can't do that on an internal network. So where do shells come from? And that's the most important part, right? So a wise man that I used to work with, I think it was Rule of Temming, once said that it's not about what, it's about where. And the essence is that with the increasing security awareness and development in security domain itself, all the network devices are becoming smarter. And because of the increasing awareness, all the network admins are also becoming proactive. I know a lot of times at conference we moan about how bad the security is, but things are improving. And so you would find most of the time these network devices being configured in a secure manner. And it becomes really difficult if a network admin, if you're dealing with a network admin who knows his job, it becomes difficult to bypass after a certain stage. So the key is to find that one vulnerable server or a service, an open port, an application that can let you in. And unfortunately, once you get access one time, it becomes very easy to pivot through machines or compromise further systems to gain further access.
So, where do you find these weaknesses? Who doesn't love Tomcat? Nobody?
Who doesn't have a Tomcat on the network?
Yeah.
That's
Really?
a stupid question, sir. Okay.
Who doesn't like JBoss. How many people know about Hudson and Jenkins? 1, 2, 3. So Hudson and Jenkins is pretty much a build automation tool. They were nice enough in building this service to give you shell access by default with the script console. So in the top screenshot is from Hudson and Jenkins. It lets you run Groovy scripts, which is Java pretty much. So it gives you this shell by default that you can run whatever Java you want into it. What is not to love about this? So we wrote Yasuo. What it is, it's a Ruby script that scans for vulnerable third-party applications. It's not a vulnerability scanner. We don't actively go out, we're not like Nessus and we say, hey, all of this stuff is a problem. We look for applications that have known issues and exploits. We support most, if not all, of the web application stuff from Metasploit. So we scan for URLs that show that these applications exist on this server, which gives you a pretty much a starting point for where you want to look. Why did we write this? So if you look at ExploitDB, there's about 12,000 different exploits on there for LFI, RFI, remote code execution, file upload, SQL injection, stuff that can give you shells. And
so basically the common applications that we just talked about, JBoss, Apache Tomcat, JMX Console, Hudson Jenkins, I mean, everyone has a different style of pen test, but these are the most common applications, or these are applications that are basically liked by a lot of pen testers. But the reality is, these are not the only applications. There are tons of other such kind of applications that are out there.
yeah. So I can barely remember to look for the top 5. I can't remember much less 10,000. Can anybody in here remember that much? If so, we're hiring. Would you like to? Yeah, so the thought process behind this was it's kind of a way to say, hey, I can't remember all of this. I need something that can for me. So we decided to go about and write this Ruby tool to do this.
I know a lot of science speakers say that, oh, I wrote this code on my way here on the flight. We definitely did not write it on the flight. I think we spent a good amount of time writing this. The code is still crappy, but we spent a good amount of time writing this thing.
Yeah. We encountered bugs that we didn't know existed in various protocols. It's amazing. So what we used to do before, everybody knows that all of this stuff runs on like 8080 or 8000. So unless you had a script to do this yourself, you go around and you poke manually. And if you're on a large network, that can take far too much time. So recently we were on an assessment where we scanned 5,000 hosts with Nessus. That took about 24 hours to complete from start to finish. We ran our tool against their entire range of about 26,000 hosts, and it finished in 2 hours. We found about
25.
So we found about 25 instances of stuff on the network that we could easily gain access to. We got domain admin, enterprise admin from there, and we called it a night, went home very happy, delivered a report, and I slept peacefully knowing that I have shells everywhere. So what's currently out there? The stuff's out there. It does some stuff similarly, but this is more, so like our tool is more geared towards finding stuff that has known vulnerabilities in there. It's more targeted to stuff that is in ExploitDB as well as Metasploit.
So we tried to create something which was very targeted towards finding pwnable targets, vulnerable applications for whom the exploits are already out there. So you can just find, the Yasuo can just find those applications, and then we can just go ahead and exploit it. We don't support exploitation and I suppose maybe we won't support exploitation, because the problem is we can support exploitation for the applications for which the exploits are there in Metasploit, but there are thousands of exploits on exploit DB, and I don't know if I trust all of them, so it won't be wise on our behalf to just execute that particular exploit. These are some of the switch options that are provided by Yasuo. So there's -F. Actually, let's start with -R. So with using -R, you can provide an IP address or IP range, pretty much the standard format that Nmap takes. If you don't want Yasuo to scan, you can scan the network, do a port scan using Nmap, and just save the result in XML format, and then feed that file to Yasuo with -F switch. And then all other switches are standard to Nmap. We don't use the actual Nmap, but we use Nmap libraries.
One thing, also for the -R, we also support input lists similar to the way Nmap does.
So new line separated values. So -B switch is brute force, and if you choose to brute force, it performs form-based authentication. So for example, I find an application, and if it's protected with default or weak passwords, and you want to brute force that, so it will brute force it for you. Be it form-based authentication or HTTP basic auth, it will brute force both of them. So if you choose -B form, it will only brute force the applications which came back with form-based authentication. With HTTP basic, it will brute force basic authentication, so on and so forth. So I was working on my slide deck. I was making this flow chart, and I was using the PowerPoint and those shady cubes and all that. And my wife walked past me behind me, and she's like, "Yeah, that looks like a really shady flow chart." And I told her, "Why don't you do it?" So she came up with this one. I'm sorry if you can't read it, but I did not have the balls to remove it from my slide deck. So the flow is like, if you provide -R switch with port IP range or IP address, then start the Nmap scan using Nmap libraries. If you provide -F and the file which from the scan that you already performed, it'll take that file, start parsing that file, and then it looks for open ports, open web-based ports, so HTTP, HTTPS, HTTP alt, WebSM, so on and so forth. So it looks for all those ports. After that, it creates a preliminary URL, so protocol, IP address, and port number. Then it starts reading the default path.csv file, and we'll talk about that file in a while. And then starts reading default application paths one at a time, and then so creates a final URL, starts sending out the request, see what the response is from the server, and then based on that, if it comes back 200, then it looks for if there's a login form, and then it dynamically extracts the login form, username, and password parameters, sends out a request, and tells you if one of the default passwords exists or not, your login credentials exist or not. And it does the same for basic HTTP basic authentication. If it doesn't find any any default or weak login credentials, then it moves on to next path and then on to the next port. What's in the box? So when you download the source code, you will find Yasuo, which is the main Ruby script. Then there's response 200, which basically deals with the form-based authentication and brute forcing. There's default path.csv, which is the key file. It contains all the signatures and also contains the paths to all the exploits associated with that particular application. Users.txt, paths.txt, it contains a very basic list of username and passwords. It depends what you want to brute force. Ideally, I would want to keep this list short, but you can also provide your own usernames and passwords in there. And so this is what default path.csv file looks like. So the first field is default path of the application. The second field is the exploit in Metasploit for that particular application. And so the best part is that we tried to make it really simple, so you can add your own path and your own exploits. The format is just simple. If you want to be really, really stealth and you do some recon beforehand, so like when I go on a pen test, the wiki page of that particular company is the most important page to me because it's just accessible without any authentication. You start digging, see what kind of applications are installed, what kind of web technologies do these companies use, and then you can just remove all the applications from the list and then target like a couple of applications or 2-3 applications and then find those on the network. A random cat picture. So what's happening behind the scenes is that it detects false positives. So have you ever come across one of those web servers that send 200 or 401 back for each and every garbage file that you request? Right. So what we initially do is we create a bogus file, and I think it is called bogus file, and it sends a request to the server with that file name, and if we get 200 or 401 or a redirect back, then we discard that particular port. There's a minuscule chance that we may be missing a legitimate application, but I didn't want to get into that at this point of time. It also automatically extracts the login form. And once it finds the login form, it automatically extracts the username and password fields and then sends a request to the server. All right. Demo. So
we have hopefully sacrificed enough to the demo gods that this will work. If not, there's a video.
Yeah, he's losing a thumb. So missing. All right. Okay, that did not come out right. This is what initially looks like with all the options. We're still on version 0.1, so we had this idea, we created a prototype. There's a long list of features that we need to implement, and hopefully we will implement those. Yeah. So for the purpose of demo, I already performed a port scan using Nmap and then saved the output file in XML format, which I'm going to use for this demo. So I'm using -b switch to brute force all, so be it form-based or HTTP basic auth, it'll just brute force everything. And crash. No, it's running. So it found an application called Zabbix, and now it's brute forcing the login credentials at this point of time.
And like we said, like the username and password lists and the application list can be weaned to match whatever technologies you're using there, so the requests will, the amount of requests you send out will be a lot less.
It found a couple of other applications. That's MediaWiki application. Then it found Tomcat. I think Tomcat is just there by default. I think sometimes it automatically installs itself. I've seen it so many times on the network. I don't think people install it deliberately. I think it just comes up somehow. And then there's an application called TestLink. Also allows you, I think it allows you to remote code execution. And so in the end, it will display a list. We're still working on the table, so yeah.
Yeah, making tables in Ruby are, without using a gem, is actually surprisingly difficult.
Or maybe we just don't know a good way yet. Anyways, so the first field is the application that it found. The second field is the exploit associated with that particular application in Metasploit. So you can just invoke that exploit after this. And the third field and fourth field are the default username and passwords. So for the first application, someone set the strong password, so we did not find the weak username and password. For the second application, actually, if you scroll up, it says no authentication. So for first application, which was Zabbix, I did not find the credentials. For second application, if you look here, it says the login page not found. Looks like this instance is unauthenticated. So actually, that page does not implement a username and password. So you get access to it unauthenticated. For the third one, again, found form-based authentication and then starts brute forcing that and finds the password admin, username admin and the password as password. And finally Tomcat and test link. So this is it. So I couldn't have like a huge infrastructure for demo, but like I said, we ran it against 26,000 IP addresses. We found a bunch of stuff and just got domain admin in like 3 hours or so. Yeah. So some of the challenges that we are facing. So initially, when we started writing this, we thought, yeah, we will support all 12,000 applications. But ExploitDB is a great resource, but the entries are not consistent. So you would see application name, v, version number, or application name, 2 brackets, and then version number, or there's no application name sometimes, just the version number, or just the application name, no version number. So it's not that easy to parse the thing out. Yeah.
So I actually tried to parse ExploitDB for application name and the URL, and unfortunately, unlike Metasploit, they don't have a very standard format across anything. So trying to programmatically build that out is a nightmare. So we'll unfortunately be resorting to the greater nightmare of doing this manually. Unless anybody has any cool ideas that they want to talk to us afterwards that might help.
So I think we analyzed, and then you could practically extract data for around 6,000 entries, and for remaining 5,000, we'll have to hire interns. The other challenge is that when it extracts the login form automatically and then username and passwords, it always will be based on the regex pattern, right? So if the page is in French or any other language, then we're doomed basically. So we basically avoid going to Paris for any pen test or things like that. We stay in the US. Future development. We will implement more smarter version detection. We're thinking of adding support for mass-scan because it's very in these days to scan the internet, and then there are already scan results out there, and it would be just convenient if we have an nmap mass-scan output file, plug it into Yasuo, it'll start finding vulnerable applications, and there's mayhem all over again. Add support for obviously more vulnerable applications. Add a secondary signature. So for some of the very common file or directory names like php/login.php, it's very generic. So we want to add a secondary signature so that we actually find what we want to find and not some garbage data. The code is really crappy. Like you can have a look at the source code, but it's deliberate. I'm afraid if you open the file, it may break. So. We'll try to add multi-threading to this thing, and also.
So the scanning the 26,000 IP addresses in 2 hours was on a single thread. So.
Yeah. Maybe we will resort to going to vFeed instead of ExploitDB. vFeed is awesome resource. It's a vulnerability aggregator, stores the data in MySQL database. So maybe it will be easier to fetch it from there. Or maybe not. Any questions or not? Sorry. Yeah. No, not at this point of time. No, sorry. Do you normally see a lot of? Sorry, do you normally see a lot of non-HTTP vulnerable? Absolutely, yeah. So other than web applications. When
you ran that against the 26,000 IPs,
right.
Did you get any indication of how noisy that was as far as people monitoring logs and those sorts of things?
So it did not trigger any network device. And so normally, so the client told us that, I know you have to scan 5,000 IPs, and that's okay. I know you would have to run Nessus, but on day one, can you try and see if you can do something else? And so that the network admins don't pick it up, and we did not hear back from the network admins for that night. And we also ran a cut down version of it, so we did not brute force all the username and passwords. We only kept like admin, admin blank, 2 or 3 combinations. That's it.
So
Absolutely. So it does. So you can either use -r switch and provide an IP range, and it will perform a port scan. So you can specify ports 80, 80, 80, whatever port numbers. Um, if you don't want to do that, you can do your own nmap scan, export the output in XML format, and then feed that file to the tool, and it'll take it from there.
And the scanning that I assume you built your own Ruby scanner for it. So,
Yeah.
so it's probably better than nmap.
Oh, no, sorry. We're not using our own port scanner. We're using nmap libraries to do that, yeah.
Thank you.
Yeah, no worries.
You can grab the code from there, and we're out of time.
Right, so yeah, you can download the code from the GitHub. We'll try to keep it updated. Like I said, there's a long list of features that we need to build in, and so we'll continue working on it. You can contact us for any additional feature requests, or if you have smarter ideas, I'm sure you do. If you do, however, want to send any abuse or any complaints about this thing, then the Steven_H and then the perfectly logical email ID is perfect for that thing.